Okay, so in the previous workshop, we looked at Git, and now we're moving on to GitHub. Now, don't worry, if you weren't here last time, these sessions are standalone, so you'll be able to follow along. If you have any questions, please put them in the Q&A rather than the chat. I'll try to answer them as we go along if they're relevant to what I'm talking about. If it's something more general, then I'll just leave it to the end. You can put questions in the chat, but I'm more likely to miss them. The Q&A is a better place. As I said, there'll be time at the end for further questions where I'll answer any questions that haven't come up and you can ask more. I'll also post a link to a feedback form. And I'm actually going to post that in the chat now. So anyone that needs to hop off early, if you could grab that and fill it in, please. I'm really grateful for everyone that's filled them in my previous workshops. It's been really handy to know what's worked well and some things that haven't worked so well. And I've had some really useful suggestions as well. So yeah, please fill that in. We really, really do appreciate all the feedback we get and we do act on it. If you want to code along, please go ahead, but don't worry if that doesn't work for you, because I'll be using quizzes throughout to keep things nice and interactive. I'll be working in AWS Cloud 9, which you can see on the left-hand side of my screen, and Launch will recommend this environment because it's easy for beginners to just get up and running. It's got everything there. But if you've got your own environment that you'd rather use, then use that one, that's fine. But you'll be seeing me using Cloud 9 today. So let's have a look at what we will be covering today. I'm wondering if this is big enough. Let's zoom in on that a bit. Oh, this is that's going to be too big. Right, here we go. So this is what we're going to look at. We're going to create a local repository. So that will just be a quick recap on Git commands. And then we'll learn what GitHub is. So we can then use that local repo to store it on GitHub. And then we're going to do 4 commands to learn how to use Git to interact with repositories on GitHub. So Git remote, Git clone, Git push, and Git pull. Now, before we go any further, it's important to understand the distinction between Git and GitHub. So Git is the tool we use on our computer to track changes to code files. And we do that by creating Git repositories. And within those repositories, information is stored that keeps records of the history of our project. So changes that have been made, when they were made, who made them. Whereas GitHub is a website, and it can host Git repositories, so we can share our projects and work collaboratively with others. And we use Git commands to interact with GitHub, but they are 2 different things. So to begin with, we're going to create a local repository that we can share to GitHub. And so we're going to do that using Git. So there's a quick recap there of how Git works and the commands we'll be using. So a little bit of theory. Git tracks changes to files using 3 conceptual areas: a working directory, staging area, and then the Git repository. So the working directory is where our code files are stored. This is where they are. This is where we make changes to them, save them, and things like that. The staging area can be thought of as like a waiting room. So once we've made changes to a file in the working directory, we're happy with those changes, we can put those changes into the staging area. And then we can make changes to a different file and put those changes in the staging area as well. And then when we've staged all the changes that relate to a particular update, then we can package those changes up into a commit and they go into the Git repository all together. So in the student notes, you can see the Git commands we're going to use to create and work with the repository. So Git init initializes a repository. So that's the thing you do when you first want to create one. Then Git add is how you put changes into the staging area. Git commit then enables you to put those changes into the Git repository. And then to view a history of the repository, we use Git log. Now, during this workshop, I'm going to create a workflow between 2 pioneers of computing, Catherine Goebel-Johnson and Dorothy Vaughan. They both worked for NASA during the mid-20th century. We're just going to use this scenario to look at creating repositories and sharing with each other. So first of all, we're going to create Catherine's local repository. So I'm just going to create a folder. such that when I'm in this folder, I'm just going to pretend to be on Catherine's computer so that we can have this fiction going of two people working together. So if I just do mkdir to just create a directory, and I'm just going to call it Catherine, like that. And then I'm just going to move into Catherine. And so now I'm on Catherine's computer. I need to now configure Git to Catherine's details. So I'm going to use the command git config. And then I'm doing global because I want this to apply to all people that work. I want this to apply to Catherine when she's working on this computer. So I'm going to use global. And I'm just going to put her username as Catherine. So any changes that she makes to the repositories are going to have the name Catherine next to them. And I'll also set her email address as well. So I just do email, and I'm just going to use a generic email address so that I don't need to change it when we come to looking at Dorothy's computer. So her email, I'm just going to change to contact@nasa.com. So these configurations are just setting the name and email address that will be stored against changes that Catherine makes to the repository. The last configuration I'm going to set is the one that ensures that Git calls the primary branch of our repository's name. So again, it's git config. I'm going to use the global flag, and in it, initialize dot default branch. So I'm initializing the default branch to main. Now, branching is a topic for the next workshop, so I'm not going into detail here, but I am going to refer to the main branch repeatedly through this workshop. A branch is a chain of commits we've made in our code, and we can create lots of different branches that have their own name to track changes, perhaps that we don't yet want in our main project. We're just experimenting with them. Today, our repositories are only going to have one branch, and we've just set them to always be called main. And we do that because, as we'll see later on, that's what GitHub expects. GitHub wants your primary branch to be called main. So we just do this. We just do it once on our computers and we don't have to worry about doing it again. This is not something you have to do every time you create a folder or a new Git repository or anything. It's something you just do one time on your environment. So now we set up the configurations, we're going to create a directory for our project and move into it. So mkdir, again, and I'm just going to call this local NASA and then move into it. So I've created a directory local NASA, and now I'm inside it. So before I create my repository, I need to have some files, and there are 3 files that you should always have in your repository before you turn it into a Git repository, and that's README. I might widen that so that it's not cut off. There we go. And then license, and then gitignore, which I've spelled correctly. There we go. So these are the 3 files that you should always create before you create a Git repository. If we look in the file tree here, here's Catherine's computer that I created. Then I created local NASA, and here I can see my 3 files: the README, the license, and the .gitignore. If you can't see the .gitignore, it might be that you haven't got hidden files set to be showing. So you go here and you do show hidden files, and then you can see it. And a dot just creates a hidden file just to make it slightly harder to change. So you tend to put things in there that you don't really want people to be messing around with. And that's all a hidden file is. Okay, I'm now going to clear the screen because I've zoomed into this. It does mess up my command prompt a little bit. So let's just clear the screen. Okay. So now we've created our local file, our local folder, local NASA, to create our project in, and we've created some files. Now we are ready to create our Git repository. And to do that, you just type git init. That's it. That's all you do. Tells you it's initialized an empty Git repository. Again, if you go into the file tree, you can see it's a hidden folder, .git, and inside all of there is all the information that Git needs to record changes to your code files. That's all that the command git init did. It just created that folder. Now, although we've created the Git repository, we haven't got any files in it yet until we commit them. So let's do that now. So I'm just going to clear the screen. So if we do git status, this will tell us the current status of our Git repository, and it tells us we're on branch main, which is what we would expect. We've only got one branch. That's the branch we're always going to be on. There are no commits yet. There are some untracked files. So those are the 3 files that we have created, and it's telling us that these are not yet tracked. So to track them, first of all, we need to stage them. And so to do that, we use the git add command, and then I could list all of the files individually, but I'm a bit lazy, so I'm just going to use a dot. So git add dot, make that a bit wider so you can see, git add dot, and that will, git add dot has now staged all of those files. So if I do git status now, we can see those files are now all green. They're all in the staging area, and they're all ready to be committed. So now I'm going to commit the files. I do git commit, I pass the M flag, and then I just need to put a reason for the commit. So I'm just going to put an initial commit for NASA. Like that. So git commit with the M flag and then string to say why I'm doing it. Now if I look at git status, a very short message. I'm on branch main, as I expect. Nothing to commit, working tree clean. So everything in the working directory and staging area is all up to date in the Git repository. So there's nothing hanging around, no files I've made any changes to that I've not put into my repository. One last command I want to show before I move on to GitHub is git log. Let's just clear the screen. So if we do git log, this gives us a history of all of the commits that have been made so far. I've only made one, so there's only one there. There's a long hexadecimal code there, which you need if you want to go back in time. Again, not for today. Then you've got the author, their email address, the date, and then the message. So we've only got one here, but when you've made lots of commits, you'll see lots of copies of this block of information. Okay, so we've created a project and a Git repository for it. And Catherine would now like to share it with other people. So far, we've only been using Git. And to share the repository is where GitHub comes in. So what is GitHub? So I think let's a little bit bigger and zoom out. See if I can squeeze on the use cases. Maybe I'll get rid of a few carriage returns. Right, there we go. So GitHub. So another bit of terminology. A local repository is the one located on the computer that you're using. So that's what we created in the previous section, is any repositories that are on your machine. Remote repositories are any repositories that are located on any other computer. And we're going to create these on GitHub. So remote repositories today are going to be ones that are on GitHub, but really they're just any repository that isn't on your local machine. Now, Git is distributed. This means there's no central repository. However, most development teams want a central repository to be their single point of truth. Otherwise, you don't know which is the most up-to-date version. And this single point of truth can be hosted on GitHub. So GitHub is just a website that can be used to store Git repositories. There are other websites that provide the same functionalities, and companies also host their own repositories on their own servers. And there are 3 reasons I've got there at the bottom that you may wish to store Git repositories on GitHub. So we might want to do it just to create a backup of our code files. If something happens to our computer, or we buy a snazzy new MacBook to update our tired old Windows machine, if we've put all of our files on GitHub, we can then copy them onto our new laptop. Secondly, we might want to let other people see our work, such as launch school TAs looking at our files for code reviews. or you might want to let prospective employers look at projects that you've done. So that's another reason to put things on GitHub. And then lastly, if you want to work collaboratively with other people on a shared code base, then you can keep it on GitHub, and then you can all work together on that code base on GitHub. So you work locally, you make a change, and then you push it to GitHub, and everyone else is doing the same thing. Now, to use GitHub, you need to have an account. So I'm just going to move this. Just going to open up GitHub's website. So www.github.com. And here we are. I'm already in here, so I'm going to log out so you can see what it will look like for you. So this is what you'll see when you go onto GitHub's website. To create an account is very easy. You just enter your email address here and then sign up for GitHub, and then follow the steps. They make this really easy for you. The instructions are very clear. Make sure you use a sensible username. I love cookies is cute, but it might not look that professional for job applications. So think about that before you create your username. And you can also select the free plan. That will be sufficient for your needs. You don't need to pay for GitHub. GitHub will prompt you to set up authentication. And authentication is just like setting up an extremely secure password. So you can't have the password. Launch School's Getting GitHub book has got a great set of instructions for this if you get stuck, although I do feel like GitHub's instructions are pretty good on this. Alternatively, if you get stuck on GitHub and the Launch School instructions don't make sense, then reach out to us in the Slack forums. That's what they're there for. There's a channel that is specifically for the prep courses, and then there's another one that's specifically for Cloud9. Both of those are really useful resources for help. There's lots of people at the beginning of their coding journey, they're asking the questions that everyone has at the beginning of their coding journey, and there's lots of people who are there to help. So just reach out, and you'll just get involved in the community. You'll just see how lovely people are here and how, you know, we really want to help each other. So before we move on, let's have a quick quiz to consolidate what we've learned about GitHub. So I'm just going to start a poll. These polls are just for fun. I can't see who has answered what. No one's recording it, so don't worry if you don't know the answers. Just have a go, and we'll have a look at the answers afterwards. So have a go at that. Okay, I'll just give you another 20 seconds or so. Let me know if I'm not giving you long enough for the quizzes, and I can give you a bit longer, but I don't want people twiddling their thumbs when everyone's finished that wants to finish. Okay, right, let's have a look at the answers. Share those results and then bring the answers up. So, what tool is used to track changes to code files? We use Git for that. And then question 2, GitHub is, these questions don't match the questions I gave you. What tool is used to share Git repositories? Question 2 is GitHub. I remember now, I changed this because this was a bit confusing for some people. Because you do need to use Git to share Git repositories on GitHub. So I struggled with how to reword this question. Sorry, I just removed it, right? So GitHub, question 3 for you, question 2 for me, is used to create a remote repository. And then the last question is, which are valid use cases for using GitHub? All of them. You might want to use it to back up your files. You might want to use it to work collaboratively and also to share files too. Okay, so now we have created our local repo and we've set GitHub up. We are now going to create a remote repository on GitHub and link the local repo that Catherine created earlier to that remote repo. Now, names for a repository on GitHub must be unique to your account. So you can't have more than one NASA repo on your account, but you can have NASA on your account, and I can have a NASA on my account. Make them descriptive, because these might hang around for quite a while, and in 6 months or a year's time, you might just go, I have no idea what that was learning to code, what's in there. So try to make your names descriptive. And then also, it's useful to know that local and remote repos don't have to have the same name. And we're going to see that because that's what I'm going to do here. So first of all, I need to log in to GitHub. So I'm just going to sign in here, and then I want to go to my actual account here. So when you log in, it will look like this. You can see some of my repositories here. And if you wanted to see all of them, list here, you can see lots of them there. There are several ways you can create a new remote repository depending on which page you are on in GitHub, and they all lead to the same place. It doesn't matter how you do it. So there's a new button here. What's always there is this add icon at the top. And if you click that, you've got a few options there, and you click new repository. So whatever page you're on, that is always available. So that's why I'm showing you that one. So we click on new repository. I need to give it a name. I'm going to call it remote NASA. It tells me remote NASA is available. I could put a description in there, and you should. I'm not going to today. And make sure it's public so that everyone can share it. So just check I'm not doing anything else, and that's it. So then just click create repository. Don't worry about the rest of it. We then come to this screen, and this is actually 4 sets of different instructions, and we only need to pick one of them. So the first one is the quick setup. When we've done this a few times, we'll just copy this URL here and we'll just be away. We won't need to worry about the rest of it. The second set of instructions, this is to create a new repository on the command line. Now, this is actually what we already did. This is creating a README file and initializing a repository, then staging it, then committing it, and making sure the branch is called main, and then these last 2 things here. So that second option, that we've actually kind of partly done that, which is why we're going to do the third one, because we've already created an existing repository on our local machine. All we need to do is push it. So there's just these 3 commands there. And then the last one is to import code from another repository. So GitHub is just one of many source control management systems out there that can be used to store code. So if you're using one of those, an alternative source, then that 4th option is what you need to do. So we're going to work through this 3rd option here to link together Catherine's local repository and the remote repository that we just created. So this is what we're going to do now. So we could just copy all of this code just by clicking that button and just paste it into our command line, and we'd be done. I'm just going to break it down line by line so you do actually know what we're doing here. So let's just clear the screen, and then I'm going to shorten this so that the commands don't keep breaking over the line. Right, so we're doing something with Git, and we're going to use the remote subcommand because we're working with remote repositories. So we've got Git remote. The next subcommand is add. we're using the add subcommand because we want to tell Git to link our local repository to the remote repository we've created on GitHub. So we're adding a link, if you like. And then the next part of the command is origin. Now, origin is an alias. This is the name that you will use in the local repo to interact with the remote repo that we're calling remote NASA. This is a convention. We could call it anything. We call it Mickey Mouse, Donald Duck. But the convention of using origin, that means when we've created loads of local repositories that are connecting to all sorts of different remote repositories, it doesn't matter which one we are in. If we use the word origin, we're always referring to the remote repository that specific local repository is linked into. So we don't need to remember the names of all the different remote repositories we're linked to in all the different local ones. We just say origin. So that is a really useful convention actually, so stick with it. So git remote add origin. So remote NASA, while we're in local NASA, remote NASA will be referred to as origin. And then the last part of the command is the URL for the remote repo. So it's this. So I'm just going to copy it there. And then I paste it in there. It's just the URL, so you can see it's github.com and then Claire McCady, and then it's just remote nasa.git. That's it. And if I execute that, this has now linked Catherine's local repository to the remote repository. So remember, locally, this project is in a directory called local NASA, but the remote repository we've linked it to is called remote NASA. And when we're in Catherine's local repo, we can just use origin to refer to remote NASA. We'll go back to the list of instructions here. So we've just done this first one here. Then git branch, the capital M flag main, that is just making sure that your primary branch is called main. We already did that before. Every repository we create on our machines now will have main as its primary branch, so we can ignore that second command. And then the last command is actually uploading the code from our local repository into our remote repository. So again, let's break that down. So we are doing Git, because we're working with Git, push, because uploading code with Git is always pushing code, so it's push. I'm going to come back to the U flag. Then we've got origin and main. So origin tells us that we're pushing it to the remote NASA because that's what we called it. We're pushing it to remote NASA. And on top of that, we're pushing the branch that we're in now, which is main. We are pushing it to the main branch of the remote NASA repository as well. So you can be in a different branch and push stuff to other branches. I don't do that. I only ever push from main to main. And then the U flag, that is just setting this origin main thing as a default. So after this, whenever I want to upload my code to GitHub, or I want to download code from GitHub in this local NASA repository, I can just do git push and git pull. I don't have to bother saying origin main. It knows that I'm always pushing and pulling to the main branch of origin, which I set to be remote NASA. So that's what the U flag is about. Okay, so I do that. It's then going to ask me for my username. So I'm not sure if I can type Catherine. I'm going to type Catherine. And then my password. And my password is my PAT token, which is a very long alphanumeric code. So I'm just going to paste that in, but it's just like pasting in a password. Yeah, I can just put whatever username I like there. So now that has pushed the changes in. So if I now go to I now go into GitHub and refresh this page. So I'm in Claire McCady Remote NASA. We can now see those files that I created on my local machine are now on GitHub. So we created a local repository on Catherine's computer, and then we created a remote repository on GitHub. We linked them, and the last step we did is we just pushed the code from Catherine's local repo to the remote repo. Now, what if we would like somebody else to contribute to our project? So here we're going to move on. So Dorothy is a part of Catherine's team and is also working on this NASA project. And she therefore needs a copy of this repository on her computer. And that's what we're going to do next. So just like I did with Catherine's computer, I'm now going to create Dorothy's computer. This is just a fiction. So I go back up to the top of my directory. I'm going to create Dorothy there and then move into Dorothy's computer there. So all I've done is just create a directory so I can pretend I'm on somebody else's computer. Just want to set the configurations for Dorothy for Git. So all I need to do is change the name. So git config global user name Dorothy. Check I spelled that correctly. I have. Right. So I'm only having to move around and set Git configurations and stuff because of this fiction of trying to pretend I'm on two machines. Okay, this is the only reason I'm doing it, and you wouldn't need to do this in a normal situation. Okay, so now we've just created Dorothy's computer and we've configured Git for her. So Dorothy needs to, I'm just going to clear the screen, it's got a bit squiffy. Dorothy needs to create a copy of the remote NASA repository onto her local machine. So she wants an exact clone of that. So to do that, you go to the repository. And so if I just go to Claire McCady and then go to repositories, I don't want to find the one that I want to clone, so remote NASA. And then there's this button code. If I click on there, there's a few different options. There's HTTP, so I'm looking for clone, and then there's HTTPS, SSH, or GitHub command line. We're just going to use the HTTPS, so we just want the URL here. So if I just copy that, I'm actually going, so anyone that's coding along, if you would like to clone this repository, I'm just going to put a link in the chat that links to a gist. It doesn't matter, just click on it and it will give you this URL, because I think you can't copy URLs off the chat, and that was a comment I had before. Okay, so now we've done that. I'm copying it from here, you can copy it from that link, and now we go back to Dorothy's computer. So to clone a Git repository, we do git clone. And then I just put in the URL of the repository I want to clone, and I can leave it at that. If I do that, Git will create a new directory called with the same name as the remote repository that we're cloning. So it will create remote NASA on my local machine if I don't pass anything else. I don't want that, because I want to be quite clear about, Catherine's got the local one, GitHub's got the remote one, and then Dorothy's going to have the cloned one. So I'm going to pass a last argument in here to be cloned NASA. And because I've done that, Git will create a folder called cloned NASA. So I'm closing down Catherine, opening up Dorothy. What I just did, created this folder called cloned NASA, and it pulled all of the code that was in that remote repository on GitHub into Dorothy's computer. We can see that because if I clear the screen, oops, and I do git log, I need to move into it first. So cd clone to NASA. So I need to move into the repository in order to see the log of it. That makes sense. So now I'm inside it. If I do git log, I can see that I've got the history that Catherine had on her computer. I'm on Dorothy's computer right now, but I can see everything that Catherine put on her computer because she uploaded it to GitHub, and then I pulled it down into Dorothy's computer. Now, we can clone this repository, and you would be able to clone this repository because I made it public. So anyone can see this code, anyone can see its files, the contents are on the GitHub website, and they can clone the repo to have a copy on their local machine, just as Dorothy has done. You don't need to be scared about this. You can't make any changes to it. All you're doing is creating a copy of it. Anyone can do that because I made it public. If you don't want people to do that, you need to make your repository private. So we've seen how to link a remote repository to an existing local repository, and then how to clone a remote repository to create a copy of that on a different local machine. So we're just going to have a quick quiz on what we've learned in the last couple of sections before we look at pushing information back in the other direction. So let's do a quiz of that. So check I'm starting on the right one. Okay, so give this a go. Gives me a chance to rest my voice. Okay, I'll just give you another 10 seconds or so. Okay, and while I'm doing that, I'm just going to answer Ricky's question. So if you were to clone it to your local computer, would it overwrite what you've done? Yes, if you were copying it into the same, if you cloned it and gave it the same folder name, yes, it would. But I think that it would warn you. If you wanted to create a separate copy of it, then you would just pass an argument in with a different folder name. Right, okay, let's end that poll and have a look at the answers. Hopefully, got the same number of questions in here that I've given you. Yes, I have, right. Okay, so the first question, what does git clone remote URL do? That creates a local copy of a remote repository. For the second question, git remote add origin remote URL. That one links a local repository to a remote repository. So you already have to have the two repositories, and this is just linking them. Question 3, links local and remote repos need to have the same name. That's not true, is it? Because we've created local NASA, remote NASA, and cloned NASA. So they all have different names. Okay, so they don't have to have the same name. And then by convention, when in a local repository, the alias given to the remote repository to which the local repo is linked is origin. So you always use origin, so it doesn't matter what local repository you're in, it's always called origin, the one that you're linked to. Okay, so let's check on that. Go back. Okay, so now we're going to upload changes to our remote repository. So first of all, let's clear the screen. Let's help Dorothy make some amazing changes to the project. So make sure I'm going into Dorothy's folder here. I'm just going to open up README. Oops. And then I'm just going to copy some text in there. Now, if you're coding along, just put anything you like in there. Okay, just README. We're having fun with Claire learning about GitHub, whatever you like. Just put a few lines in there. Could be gobbledygook. Just make a change to the README file. So I've now pasted that in there and saved it. So we've made this amazing change. Let's just clear screen. Oh, not my name. There we go. So we're going to check the status of the repository. So git status. This is what we'd expect. We've got a red line there. We've modified README. We've not staged that change and we've not committed it. So that's what we need to do. Let's stage it first. So I'm going to git add, just one file. So I'm just going to add README. And then I want to commit that change. So git commit, pass the M flag, and then I put added plans to orbit Earth, just like that. It's very exciting. Okay, so I made a change to the README file, I staged it, and now I've committed it. So if I look at git status now, I've got git status on branch main. Got this little message here saying your branch is ahead of origin main by 1 commit. So this is just telling us that since we last downloaded the Git repository to our local machine, we've made a change. So we're now ahead of what is on GitHub. Now, Dorothy wants to share her amazing change by pushing the code from her local repo to the remote repo. And she needs to push the code because although her local repo is connected to the remote repo, GitHub doesn't work dynamically. Local changes don't just appear on GitHub. You have to push them up there. That's actually a good thing. So local changes that you make have to be manually updated to the remote repo. And to do that, we do git push. And then I'm in a new repository. So I'm going to have to pass that U flag again to set up the origin main defaults. So I want to push the code from where I am, which is the main branch of cloned NASA. I want to push it to origin, which is set to be remote NASA. And I want to send it to the main branch there. So that's what I do. Now, if you try and do this, you won't be able to because you won't have my password. So I hope you don't. So I need to copy my password in again. So I can do this because although I'm pretending to be Catherine, Dorothy, actually everyone is just me. And so this is my repository. And so I can push and pull all I like. And if we have a look at that repository on GitHub now, I'll update it. We can see the README file here is just automatically displayed. It's the file that is just automatically displayed. To see any of the others, you need to click on them. We can see here that the change I made on Dorothy's computer is now on GitHub. So, as I said, the reason I can do this is because I'm actually both Catherine and Dorothy. And if you try to push changes to my repo, you won't be able to because you don't have permission. I'm just going to look at that quickly by looking at these 3 scenarios. So the first scenario here is storing repositories on GitHub that only you can change, but others can access. So when you back up your files or store projects for launch school TAs to look at, this is what you will be doing. You'll be able to make changes to your local repo and push those changes to the remote repo you link to because it's yours and you've got permission to push code to your own repos. The second scenario reflects Dorothy's situation. She is working on Catherine's team. They're working together. So they and other people in the team have all got permission to push code to that remote repo. And then the third scenario is where you are if you cloned my repo. If you want to make a change to somebody else's remote repo on GitHub, so you've made a change and you want to push it to my repository on GitHub, you can't just do that, which makes sense. I don't want you just changing stuff on my repositories. Instead, you submit a pull request, which is sometimes referred to as a PR. So you might have come across that. So you submit a pull request, and this would ask the owner, so it would ask me to pull your changes into the remote repo. And you'll see if there were any, they would be listed here in GitHub. I'll be able to see here. But there aren't. And so I would be able to have a look at it before I went, oh yeah, actually this person's got a point. This is a really great change. I am going to pull this in. So this is beyond the scope of today's workshop, but I just wanted you to be aware of it for the future for when you are working with other people. And if you try to push your changes to my repo, why you wouldn't be able to do it. So let's now go back to the originator of the project. We're going to go back to Catherine. She's heard that someone made this amazing change to the NASA project, and she wants to download this, these changes to her local repo. So where are we? We're here. That's everything. Okay. So go back to here. I need to move back into Catherine's computer because I'm currently in Dorothy's computer. So let's move back to Catherine, and I'm going to move into the local NASA repo on her computer. So if I just do clear, I'm now on Catherine's computer and I'm in the local NASA repo. If I do git log, here we can see that we don't have Dorothy's commit here. We've only got Catherine's commit. And we can also see that locally, we're completely unaware of that change that has been made to GitHub. This local repo thinks that it's up to date with the one that is Origin main, the main branch of Origin. Remember, Origin is this remote repo on GitHub. Locally, we think we're up to date with it. And this is what I'm saying, when GitHub doesn't work dynamically, it's not working dynamically here, it won't know unless you tell it. So as far as it knows, it's up to date, but actually it isn't. So to get up to date, I'm going to just do git pull. And because I used that uflag origin master before, I don't need to keep putting that. I'll just do git pull, and Git knows that I want to pull the main branch from origin down into where I am now. I'm in main. So I'm pulling the main branch from the remote one into the main branch of the local NASA one. So I've done that. It's telling me one file was changed and there were 3 insertions because I added 3 lines. And then to satisfy ourselves that we've downloaded the latest version, if I do git log now we can see the 2 commits. So they're in chronological order with the most recent one first. So Dorothy's one is first, and then Catherine's original one is next. We've only made 2 commits, and those are the 2 commits listed there. So we can see that to start off with, Catherine created a repository. She uploaded it to GitHub. Dorothy cloned it, made a change, uploaded her change to GitHub, and then Catherine downloaded it. So that is the workflow that we've done. So let's have another quiz to recap on the 2 commands we use to interact with the remote repo on GitHub. Let's get rid of the answers there. Okay, there's just 2 questions here. So give that a go. Okay, just give you another 20 seconds or so. No one said I'm not giving you long enough, so I think I'm judging it right. Okay, and remember, if anyone needs to hop off, I mean, I am nearly done, but there is another quiz for people who are keen on quizzes. So I'm just going to post the feedback form there for anyone that needs to hop off early. We've still got another 10 minutes or so. Okay, let's have a look at the answers. So git pull is what you do when you want to download code from a remote repo to a local repo, and then git push is what uploads code from the local repo to the remote repo. So once you've been working with Git and GitHub a bit, this becomes second nature. But git pull is downloading and git push is uploading. Okay, so that is, we've covered everything. So let's just have a look at what we've covered. We created local repository. We learned what GitHub was. We then created a remote repository and connected the local one to the remote one using Git remote. We also created a local copy of remote repo on Dorothy's machine using git clone, and then we use git push and git pull to upload and download changes from the remote repo. So as you can see, we actually only used 4 different commands to interact with GitHub: git remote, git clone, git push, and git pull. So it might seem a bit complicated to begin with. This is new, but practice and it does get much easier. And just bear in mind that actually there are only 4 commands we're using there. So whilst Git and GitHub can be huge topics, you don't need to know much to get started with it and get a lot of the benefit from these tools. So to get familiar with all the commands, you need to practice. So create a local repository on your machine, create a remote repository on GitHub, link them, make changes locally and push them up to GitHub. If you want to practice pulling code, then you need to do what I did and pretend that you're another computer on your computer, and then you can pull stuff. It's good to practice doing this before you really need it, because it can be quite stressful to learn something when you're at the point at which you need it to work. So practice now when you don't really need it. I mean, Git is really useful. So I mean, as soon as you're doing something that's more complicated than just a calculator, I think Git really helps. And in the next workshop, I'm going to show you some of the reasons why it really, really helps. So my advice is just, you know, get practicing, use it. Don't be scared of it. There's nothing to be scared of here. So now I'd like to give you a chance to ask any more questions that you've got. And while I'm waiting for those to come in, I've got one final quiz to give you for a summary of everything that we've learned. So I'm just going to launch that now. And then have a look at the questions that are Muted. Okay, so let's have a look at the answers. So just end the poll. I think I gave the answers before I ended the poll. Right. So to create a copy of a remote repository, you use git clone. So git clone remote URL. That is what you use to create a copy of a remote repository. The second question, to download contents of the remote repository into a linked local repository, you need to use git pull. And then question 3, to upload contents of the local repo, you need to use git push. And then the last question is to link a remote repository to a local one, you use git remote add origin. Now, I think most people have got these right, which is great, but don't worry if you haven't, because this is absolutely something that's fine to be looking up to begin with. Once you've done it a few times, it does become second nature, but don't feel like you need to sit and memorize this. This is something that just comes with practice, and the more you do it, the more obvious it will become. So don't worry about, I mean, I know these quizzes, I'm asking you to memorize these things, keep you on your toes. Don't worry if you didn't get all the questions right. This isn't something you need to rote learn. You will learn it as you practice it. So next time. So I hope you've had fun today and that you've learned things. I think I've answered all the questions that came in. Unfortunately, I can't help people troubleshoot if they're having problems on their own personal system, because it will depend on what configurations are set up and things. I just can't do that. But there are those 2 Slack channels where we can help you. So it's the prep course one and the AWS Cloud9. Both of those, there's lots of questions that goes in those from people at the very beginning of their learning journey. And so we're used to people asking questions that, you know, people were, if they're asking stupid questions, there are no stupid questions. If you're asking the question, then other people will have asked that as well, and you need help. And it's important to get help to unblock these things. And we're just much more able to help you there because we can ask the screenshots and see what's going on. So if there's any questions I couldn't answer today, then ask in there. And C1 has come in. Do you link a remote repository to a local repository after first cloning the remote repository, or it's vice versa? So cloning is when there's a remote repository on GitHub. It exists already and you want it on your local machine. That's what you clone. If you've created a local repository on your local machine that you want to put on GitHub, then that is when you link the remote repo to your local repo. So they're kind of opposite things, aren't they? If there's one already existing on GitHub, you clone it. If there isn't and you're creating it locally, you want to create it on GitHub, then you are linking a remote repo. Thanks for clarification. You're very welcome. I'm glad that helped. Okay, so today we've learned how to create and work with remote repositories, including cloning repositories, pushing code and pulling code. Next time, we're going to learn more about Git, such as undoing unwanted changes, branching and merging. And when you do these things, this is when you really learn the power of Git, even when you're creating something very simple like a tic-tac-toe game. By using something like branching, you're not sure whether this bit of feature you're going to create, you don't know if it's going to work. You create a branch and you can mess around in there. If it doesn't work, just scorch it, go back to your code, everything's still working. If, on the other hand, that does work, you just merge it back in and you've progressed your project. So branching is incredibly useful. And as you can imagine, undoing unwanted changes can be really useful too. And that's what you'll learn next week. Now, it is a longer workshop to give me time to explain things. So it was planned to be an hour, but I've run it a few times now and it's 90 minutes. So plan to be here for 90 minutes. Most of the information you'll get after an hour, but there will be a bit more after that hour. And it does enable me to not rush through it. So when people ask questions, I can stop and make sure everyone catches up. So it'd be great to see you. Next week's one I think is really, really useful. And then I guess all it is for me to say is, you know, it's great participation in the quizzes, which I love to see. Lots of great questions as well. Please fill in the feedback form. I've just put another link in there in case I haven't pushed this enough. Really do appreciate the feedback, even if it is just to say Claire's just brilliant, she's wonderful, don't change a thing. Even that is useful to know. But any constructive criticism is really helpful as well. It's only because of the feedback that I've got from previous feedback forms that I feel like this is as it is now, because I've used the feedback that I've got. So please fill in. Okay, so hopefully I will see you all next week. So enjoy the week. The weather here is getting all spring-like. We're all excited. You know, a little bit of hail today, but I'm sure that was just temporary and it's going to be warm again. Yeah, have fun with Git and GitHub, and hopefully I'll see you next week. Goodbye.